Thank you all for coming. In this presentation, I'd like to take you on a journey to explore some uncharted legacy features of Excel that resulted in a vulnerability that allows an attacker to craft a signed phishing payload. This payload would result in the user seeing a legitimate Microsoft signed document or no security warning at all. We're going to see that it is possible to inject code into a Microsoft signed document without invalidating the signature, and thus effectively reusing this Microsoft signed document as if code signing. Microsoft assigned a CVE for it in the category remote code execution. But before diving into the content, first a quick introduction. My name is Dima van de Wouw. I'm a red teamer and offensive developer at Outflank. I really like to develop things that break things and then using them in operations. At Outflank, we're specialized in red teaming, giving trainings and offensive security tooling, and we also put stuff on our GitHub and perform research, for instance, in the fields of phishing and Office. This inspired me to start my own journey into this field. I'd like to start this presentation with a little bit more background on the journey, then some background on Office, to give a more context about why this was interesting. Then I'd like to go from identifying a vulnerability, then moving into creating our very first proof of concept, into fully weaponizing this vulnerability that is also allowing me to use it in client engagements. And then later we'll see what Microsoft did to mitigate and patch this issue. The story started simple, with a simple problem statement. I would like to create a better phishing payload. And a phishing payload needs to have a few properties, right? It needs to have a cool icon, and it needs to be double clickable, because I want user convenience for my phishing target. The process I wanted to apply is, I would like to look around, learn stuff and understand things better, and then search for something that feels a bit off, feels a bit weird, funny, shady, and then dive deeper into it. And then repeat this process over and over. And my starting point was Office file types. Like, I wanted to identify and understand Office file types, and I started out with using the file and the save as dialog. So I save a specific file with a different extension each time, and do some comparisons between that. Furthermore, I downloaded all kind of random stuff from the internet, and I searched in the C program files Office installation directory. When looking through the installation directory of Office, there were some example files, let's say, XLAM files. No clue what those were, but there were a few of them around, and they had a cool icon, so let's see what those were. But there was also one file that caught my attention that I was all too familiar with. An XLL file. So what is going on here? Are these files consuming or using this XLL file, or what is an XLAM file anyway? An XLAM file is an Excel add-in. And an add-in is not really a sheet, it's an add-in. It adds functionality to Excel. And in this case, ATP VBA is the Analysis ToolPak add-in. It adds a button to the Excel bar. Well, if you click on it, you can you get more options, and you can do all kind of analysis on your cells or your worksheets and perform other cool calculations. So what happens if I just copy paste this XLAM into another directory like ctemp? Upon opening, double-clicking, which worked, I got a security warning. And the security warning said a couple of things. It said that the digital signature is valid and that it contains macros and if I wanted to enable them or not. So I enabled them and then the functionality kept working, possibly implying that it could load maybe some other resources from the Office installation directory. But then I was thinking, like, what happened if I also put an XLL in the same directory with the analysis32.xll name? But instead of using the one from the Office installation directory, I just create my own malicious unsigned XLL and hit the enable button. Bam! My XLL opens. This is really interesting. So my malicious unsigned XLL is loaded from a signed context. And it loads, in this case, an explorer of a CMD window and a small pop-up. Let's do a small recap so far. So we looked through the Office installation directory and it contains some signed files. These signed Excel add-ins can be moved to another directory without invalidating the signature. And I can also replace the XLL by my unsigned XLL, and the add-in will then run from a signed context an unsigned XLL. And this is potentially really interesting, because if a user will see that something is signed by Microsoft and the signature is valid, then it must be legitimate, right? This could be potentially great for phishing. So let's see what happens. Let's do first a little bit of Office background, and specifically Excel. Excel is not only amazing for normal users to create really cool spreadsheets and do whatever they do, but also great for programmers to automate things in various ways. And these various ways leads to all kind of various file types. And Office has many security features to protect users from malicious actors, while still allowing normal programmers to automate these things. And I'd like to go through a few of those protections. First, we'll talk about Excel security dialogues, then we talk about various file types, and then about the trust flow. This is a security warning. This is the normal macro warning from an XLSM. This is a slightly different one. This is if you combine macros with active remote content. This is a warning from an add-in. It looks totally different, and it's more like prominent. It asks it to enable macros or leave them disabled. And this is a security warning for an XLL. This doesn't contain the scary word macro, but it just mentions add-in, which already sounds a lot nicer. So let's do a little bit of a file type comparison, because these security warnings, they're influenced by also file types. So this is the normal XLSX, this is a worksheet. Then you have two file types that have macros embedded into them, and macro code can be signed. So, and if you have a valid signature, it will result in a different dialog. And there is an XLL, which is an Excel add-in. It can also contain code, but not in the way you would possibly expect it. And the extension can be important for phishing, because if you have a more mature target, you might want to take a different extension, like something that is less common, or something that I possibly not have had in the training, or an extension like XLS that you do not necessarily see from the outside if it contains macros or not. So what is this XLL? This XLL is actually a DLL, a portable executable. And XLL can only be loaded if you have an XLL that is the same bitness as your host process. So if you have a 64-bit Excel version running, then you also need to fish your target with the 64-bit XLL. And likewise, if your target has a 32-bit Office, then you need to fish with a 32-bit XLL. Yes. What is also interesting is, just to get back to the XLL, it's really interesting to use one of those because you can just natively program. You can use OPSEC-safe C++ with direct system calls, all your code obfuscation and anti-reversing, whatever you want. It provides great benefits. What's also interesting is that it doesn't support mark of the web. And mark of the web is a security attribute that is set on a file if you download it from the internet or if you save it from an attachment, for instance. Basically allowing Office to choose a different dialog. Let's quickly look into the file format of the left three files, the Office Open XML file format. That is basically a zip. So you can unzip it using just your default zip tool or 7-zip. And it contains all kinds of XML files. While browsing through it, you'll see a couple of files, such as the VBA project.bin file and possibly, if it's signed, a signature.bin file. And this is the part of the document that is signed. And in theory, all the other XML files in all the other directories are not signed. And in theory, you can even transplant these signed files into another file and thus lift on the security notifications and the signing. When looking at the XLAM file, there was also another thing that was interesting to note. The difference between an XLAM add-in and an XLSM sheet was just one word in one of the XML files. So by replacing this add-in word with the word sheet, I can also just quickly change the extension of the file and thus move from one file to another. And then from an XLSM, I can use the file save as dialog in Excel to then move to other file formats and thus gain flexibility on fishing my target with different kind of extensions. Let's look at the trust flow. So if a user opens a file that has macros enabled in it, and the file has the mark of the web attribute, so meaning that it comes from the internet, then Excel or Office in this case would go through a certain flow, querying all kind of register options and whatnot to verify if it should run the macro or not, or give a dialog. So if it's in a trusted location, then macros are enabled for sure. If it's digitally signed and the trusted publisher is on the PC, then macros are enabled, and so on and so forth. But how does this work with XLLs? Because they don't have the mark of the web. Then you'll enter a different flow. And like this, Microsoft Office has various flows and nuances and exceptions that allows you as an attacker to work and try to bypass the different things. What I would like you to remember from this slide is that the trust flow has many nuances and exceptions and is quite a complex thing. So, small recap. Most of the Office file types are OOXMLs, so are zips, and are openable. Only the macro is signed, so all the worksheets, they can be freely edited without invalidating the signature. An XLL is an Excel add-in DLL, which is really interesting as a file type because it's different and it can allow you as an attacker to have various OPSEC safety features, and there's different file types and dialogues. Furthermore, the trust flow is complex and has many nuances and exceptions. Let's do a deep dive in the analysis ToolPak. What is it? How does it work? Is it vulnerable? Can we exploit it? Can we misuse it some way to phish a target in an interesting way? First, when I would try to look into this, I used Excel and I wanted to try to go to the macro editor and extract the VBA code or look at the VBA code. Well, this was password protected, so I had to use another trick, or another tool. I used OLE-VBA to extract the macros, of course, out of the document. OLE-VBA is a really nice tool, and it will just print the macro code and also give you a nice summary. And this summary mentioned auto-execute, auto-open, suspicious, run, register, and execute Excel for macro. So this is all the more reason to continue deep diving into this document and to see what is going on. Looking at the VBA code, if you distill it down, there's only 100 or so interesting lines of code left. So let's analyze these. Let's start at the beginning. In the beginning, you'll see that a couple of cells are kind of named and referenced. It has an auto-open function, as we already figured out, which calls for more functions. The first function isn't really interesting. It just contains a lot of constant values and doesn't really do that much. But the second function is already a bit bigger. It's the pick platform function. And this function is Windows or macOS aware. Hinting that both Windows and macOS are supported and possibly vulnerable. And then you'll see that a few cells are being referenced and the value within the cell is being saved within a variable. Interesting. So how would that look like? So the XLAM, if you perform XLAM, if you convert it to a sheet and then unhide the work spaces, you'll find that it has some XLL names and directory separators and whatnot saved into the cells. And for this talk, we can basically exploit all the functionality within this add-in by just using cell B8, the XLL name, Analysis 32.xll. So for the remainder of the talk, we're going to focus on cell B8. So how is an XLL being loaded then? How is this XLL name being consumed by the rest of the VBA code? So we already figured out that the code runs on open, and then after the pick platform function, the verify open function is being called. The cell value is being stored in a variable called XLL name, and then later being consumed by this function called register XLL. Pretty much without any input validation or so whatsoever. If you look to the remainder of the function, you'll see that all the other variables and code flows that use the register XLL function are also vulnerable. And important to notice is that if no valid XLL is found, the worksheet is closed and all macro code execution will stop. So any further VBA code will not be called. So this is like a hard process exit. So it is important that this macro code will find a valid XLL. So small recap. Analysis ToolPak runs on open. It will load an XLL and the name in the, from the name in the worksheet. Cells are not part of the signature, so they can be freely edited without invalidating it. Register XLL loads on XLL, also unsigned ones. And Office for Mac also seems to be supported, hinting that it is also vulnerable. We're going to focus on Windows for now. Let's try to make a very first proof of concept. So how would that look like? As an attacker, I would like to change the file name of the Analysis ToolPak add-in to something else. Possibly it's something that would, for instance, complement my phishing storyline. Possibly also changing the file extension. I would like to change the file name of the XLL and maybe also the extension of the XLL to steer the user away from clicking on it because it's unsigned and to steer them towards clicking the signed XLAM, the add-in macro. This is to lower the lower suspicion, for instance. And I would like to load the correct bitness of XLL according to the environment that we're running in. So I would like the add-in to choose whether to load a 64-bit or a 32-bit XLL. Let's try to make a very first proof of concept. So this is the original version. This is the normal flow. And in the normal flow, this analysis 32.xll is obtained from cell B8 and then used in register XLL. Let's change the value within the cell into demo 64.dot. Success. So we can change the name and the extension and the XLL still loads. Okay, let's continue. Let's use, instead of a static string, let's use a formula inside of my cell to calculate whether our current Excel host process is 64-bit or 32-bit. And that also worked. So for a 64-bit Excel, demo 64 would be loaded, and for the 32-bit Excel, demo 32 was loaded. Let's use the previous trick to go from an XLAM to an XLSM by changing this single word and also changing the extension, and then using the file save as dialog to go to an XLS. And the reason why I would like to change to an XLS is because from the outside you don't necessarily see that it contains macros, contrary to an XLSM where you see that it has possibly macros. And this is how a very first proof of concept would look like. It has two files that are not clickable, well, on a normal system, not clickable, and an XLS file that is. And if you could bundle them up in a zip, or a 7-zip, or ISO, or image, whatever, we can send it to a client and then possibly gain initial foothold. So a small recap, Analysis ToolPak loads an XLL from a local path. You can use like a relative path or absolute path. You can change file names and extensions, and you can use formulas to calculate your current bitness, 64, 32-bit. And it's possible to change to a different file type. And that would be the end of the story if I just wanted to make a proof of concept. Because this, in theory, is already sufficient to report to Microsoft that there is something interesting here, and that would basically end it. Or we can try to fully weaponize it and make it as powerful and dangerous as possible and see how deep this rabbit hole goes. So let's do that. Let's improve upon our current proof of concept by not providing 3 files in a zip or something like that, or providing multiple files, but to actually load this XLL from a remote location. But then we run into our very first problem. Register XLL does not accept any URIs or URLs, so you cannot start with HTTP or HTTPS because, well, for obvious reason, Excel doesn't want you to load from a remote DLL over HTTPS. But luckily, UNC paths, like also including SMB, were allowed. And this gave another interesting possibility is to use WEBDAV through UNC. Though WEBDAV requires you to have the web client service on the target PC running. And starting web client requires a manual trigger or the manual start of this service because it doesn't start automatically when the system boots up. Furthermore, it also requires administrative privileges to start it manually. Luckily, there is ways to start it using a trigger that do not require administrative privileges. So we have a choice now, either to send an additional file or something that would, for instance, maybe trigger the web client service. For instance, a Word document with a remote template could work. Or we create a small Excel gadget to start this web client service. Let's do that. So there's a couple of gadgets you can use in Excel to trigger the web client service, and one of which is a very simple one. You just reference a remote cell. So instead of typing a formula, or instead of just putting some text into a cell, you just tell Excel, look, the content of the cell, we have it, but it's just all the way over there on this HTTP address. And Excel would fetch that content, thus triggering web client. And we could use this in a certain way. Like, remember that the workbook would close when no valid XLL is found? We can abuse the error message being shown just before that. So the first time a user would double-click on this infected add-in, register XLL would not be able to reach the WEBDAV location because web client is not running. It would try to load an error message from this remote location, triggering web client, and then the workbook would close. The second time, our target would double-click on this add-in. Register XLL will be able to find this remote WEBDAV location over HTTP or HTTPS, and then our malicious XLL is loaded into the Excel memory. Of course, this would require some social engineering or phishing, or just a user that is just really happy to see what we have in this Excel sheet. So this requires a user to open this file twice. Which is good, it's already better, but we want something more. We just want something really nice, like one file that fully exploits the target just after this enable macro button is clicked, that works on any Office version, any Windows host version, 32-bit, 64-bit. We basically want a golden bullet. Let's see if we can find that. Luckily, there is one function we haven't looked into yet. Let's do a small recap. So the first function has some constants. Then there is some OS variables being set. Then we have our vulnerable register XLL function. And then the last function is actually very short. The last function does a register ID, performs an execute XL4 macro on a concatenated string. And this string that is being fed into the execute Excel4 macro function is being concatenated from some static content and some content that was originally found in the cells. This is a classic command injection. And an interesting one because Excel4 macros at the time did not have any AMSI support. AMSI, anti-malware scanning interface, is an interface for instance, AV and EDR vendors to hook into and try to detect malicious activity. So this is a stealthy way to continue our phishing. Let's look at the normal flow. And looking at the normal flow, you'll see that register of the verify open function with register XLL provides some kind of input validation. Because if no valid XLL is found, then we're going to close the workbook and end our execution before register function ID function is being called. So we already need to know in advance what our target, that our target has a valid XLL and where it is located. Luckily, we don't really need to, because Excel has a custom XLL and DLL search path. So it also takes into account its own installation directory. And using the default values, we already know where an XLL is located. It's located in the library analysis folder. So we're going to use that. Let's see if we can still use this path, but also add some malicious code into that. Let's see if we can pop a calculator application. We're going to try to do that by injecting some code and then traversaling it back. So we're going to put our code in a dir traversal. Register XLL will perform path normalization and thus remove the code, ending up with a valid path. But register of execute Excel4 macro will concatenate everything together as if it is a normal string and then feed it to the function. We can escape the quotes and basically get code execution. So a new Excel window of a new calculator window is opening. We learned we can put malicious code into a dir traversal. Now, let's go to remote code execution. Let's host our XLL on a WEBDAV share and use the same trick to register it. We have to perform some more dir traversal because we're using backslashes. String call will look like this, and this will get executed. And that would work sometimes, because here as well, register is not allowed to start the web client service. But luckily, we can use the same trick by referencing a remote cell. We are going to use the function run. So we are going to use the function run on a remote Excel sheet and reference, for instance, an empty cell. And then we're going to use register. And this one works. Victory. Run triggers the web client service and register loads the 64-bit XLL. So now we want to make our final proof of concept. Before that, I also want to mention that it's also possible to load an add-in macro or a macro sheet, enabled sheet. And well, this would be an option and maybe a bit of an easier one, but you will still remain in macro land. I want to load a portable executable. Let's do that. So first, we're going to start with a string, like the first part of our exploit string will be put in a cell. Then we're going to take another cell that will be a formula that will calculate which URL to use, a 64-bit URL or 32-bit URL. And then we're going to end with another static string. We're going to concatenate those three cells together and thus have our exploit code. And this worked brilliantly well against 64-bit XLLs, 32-bit of 64-bit Excel, 32-bit Excel on various platforms and OSs. So we found XL4 micro-injection. We used the verify open bypass. We bypassed verify open by using a dir traversal and by referencing a remote relative reference. And we now have one file that we can send to our target. This is interesting because it allows for little to no pre-knowledge to perform our phishing. And when we tried it, we noticed something strange. When testing our weaponized version during engagements, we noticed that the users of some of our clients did not receive any warning message or security notification at all, while they should have, according to the settings that we saw. And this is because the publisher that signed the Analysis ToolPak macro was already noted as trusted. And this was required in a few very weird, special border cases. If you want to install Visual Studio, if you want to do an offline installation of Visual Studio on older operating systems, or if you have some security patches that you want to install offline, then you need to add this certificate to your trust store as well. Though, you only have to add it to your operating system's trust store, not additionally to your Office trust store, and also not on all endpoints, just on the relevant ones. So there were also some misconfigurations found at these clients. And these misconfigurations led to a very dangerous situation, because if I would make an XLS, then it would not be possible, or it would be very difficult for an end user to see if there's macros enabled or not. Because once you double click, you don't get a warning, and it just opens. So, how did Microsoft mitigate and patch this issue? This wasn't necessarily an easy issue to patch, because every semi-annual release, there were new add-in sheets signed by Microsoft. Furthermore, looking at the samples we found online, we noticed that this vulnerability and these signatures were out there already for more than 10 years. Furthermore, these signatures, or these sheets, were timestamp signed, meaning that the signature is valid indefinitely. And Office doesn't support any certificate revocation lists, meaning that by design, there is no revocation option. It took Microsoft quite a while to come up with a patch, and in the meantime, they assigned a CVE in the category remote code execution. And they patched it using a couple of different methods combined together. The first one, of course, is they patched the vulnerable VBA code. Now, instead of using cell references, they just hard-coded the correct values into the VBA that was signed. The execute XL4 macro function did not need much more patching after that, after everything was hard-coded, but even then they also did quote escaping. And they hard-coded blocked all the old add-ins from running. And they added another option with a registry setting to prevent any signing downgrade. So now you cannot go from a signed context into an unsigned context. So you cannot load an unsigned XLL from a signed add-in, for instance. Let's wrap it up with the main takeaways from this talk. we accomplished to explore some of the uncharted legacy features of Excel. These resulted in a vulnerability that allowed an attacker to craft signed phishing payloads, where users would see that it would be signed by Microsoft or no warning at all. It would work against almost any Windows machine with Office installed, and it worked by injecting code into parts of the document which weren't signed, so without invalidating a signature. This vulnerability was there more than 10 years, and we believe that there's many more of these kind of signed documents or other legacy features out there that are vulnerable. So I hope that my talk was inspiring to you to go and find out some of these more legacy features. Thank you all.